Alright, so our lesson is on permutations. So let's start by defining. It's an arrangement or a listing. Bless you. Arrangement or listing of objects in which order is important. We can also use the fundamental counting principle as we're finding these permutations. Alright, so let's get into some examples. Alright, so Julia is making her class schedule. So it sounds like she must be in college where you get to pick your classes. Maybe you can do some of that in high school. Alright, so her choices are math, science, and language arts. We're going to find the number of ways she can schedule her classes. So for these permutations, some of these numbers are going to get very large. So you will need to have your calculator. Because what you do is you think, okay, she's got 3 classes to schedule, 3 choices. Alright, so we start with 3 classes available. So there are 3 classes, 3 choices for class 1. Okay, you with me so far? We had 3. She has 3 classes to choose from, math, science, or language arts for the first one. Now, once she makes a decision and picks a class, how many are left to choose from? Okay, so then we multiply that 3 by 2, because when she goes to make her second choice, she's already used one. Does that make sense? It's like you had 3 marbles in a cup. We drew 1 marble out, and we're not going to put it back in the cup. There's only 2 marbles left to draw from, and so you have to pick from what's remaining. Alright, and then when she goes to choose her third class, is there really a choice? No, there's only 1 remaining. Alright, so then to find the total number of arrangements that could possibly happen, we just multiply it all together. 3 times 2 times 1. So that will equal 6 permutations of the 3 classes. Okay, in the next example, we're going to an ice cream store. So the ice cream shop has 31 flavors. All right, so Carlos is shopping, and he wants to buy a 3-scoop cone. And on his 3-scoop cone, he wants to have 3 different flavors.
You forgot to put the D on 5. At the top, she can schedule for classes. Is that fair?
Point to it. I don't
Find
know.
the top. It says just find the number of ways.
All right, so how many cones can he buy? If the order of flavors is important. I want you to pay attention to this wording. So if you see how many and if the order is important. These are going to be your clue words to know that you'll need to do the permutation with it. So basically they're saying, okay, how many possible arrangements are there of ice cream flavors on this cone? Okay, so he wants 3 scoops. So on his first scoop, how many choices does he have total?
31.
So on scoop 1, there's 31 options sitting there in the cooler that he needs to pick from. All right, so 31 flavors. So 31 choices for first scoop. Okay, so now on the second scoop, how many choices will there be? Because remember, he wants a different flavor on every scoop.
30.
So now on the second scoop, he's only got 30 flavors to choose from because he's used one of them. Okay, now he's going to make his third scoop choice. Well, how many choices are left for his third scoop? 29. Okay, now for this problem, I'm not going to keep going until I get to 1. Because how many scoops did he ask for? 3. And I've got 3 right here. That's as tall as the ice cream cone will be. So now in my calculator, hold on, I forgot to write this. 29 choices left. Bless you. All right, so in my calculator, I type 31 times 30 times 29. Look what we get. 29,970 different options that he could have, or arrangements he could have made for his cone. that not what y'all got? Or is Siri trying to tell us something different? Oh, that's a plus. Oh, I reversed the numbers. Sorry. Or actually, I wrote the wrong number down on my notes. Sorry. Yeah, 26,970. I must have been really sleepy last night after field day. Yeah, 31 times 30 times 29. 26,970. There we go. My bad. All right. So really, the basic idea of what we need to do here is not a difficult thing to do, but you will need to be able to recognize that it's a permutation so that you'll know what to do. So here's another example. All right, so in how many ways can the starting 6 players of a volleyball team stand in a row for a picture? So if you imagine we have a nice straight row of our volleyball team, we can put one person in slot 1 of that row, right? Okay, how many choices are there for that slot 1?
1.
How many are on the team?
6.
So how many are in that slot 1? I can choose from 6. Now I have to place somebody in slot number 2. Well, how many choices are left now? I've placed one person. There's 5 left. Now I've got slot 3 in my row. How many are left now to choose from for slot 3?
4.
Okay, 4. Then there's 3 to choose from. Then 2. And then that last person, whoever's left, just goes in that last spot. Bless you. Alright, so there's 720 different ways to arrange them. What if we have a race? And we have 7 runners. In how many ways can the runners end up in first, second, and third place? All right. How many choices are there for slot 1? First, second, and third? I've got what? 7. What about for the second slot?
6.
And the third slot?
5.
Now, am I going to go down to the 4? I don't need to, because how many places am I giving?
3.
First, second, and third only. So all I have to do in my calculator is 7 times 6 times 5. So there's 210 different variations. Okay, now it's not always going to be a word problem. These are word problems. Sometimes they're going to just have, I don't want to say a formula, sort of like a symbol that you'll look for to find the permutation. Let me show you what that'll look like. So let's say it says find, and it says P, and then 8, 3. All right, so it might just look like this. This P means number of permutations. The 8 stands for 8 things. The 3 is like 3 at a time. Kind of like in this last problem here, it would have been 7 runners because of 7 things, and 3 because of 3 places, first, second, and third. Does that make sense? Okay. All right, so then to solve this here, all we have to do is say there's a total of 8. That's our biggest number. 8 times 7 times 6, because I only need 1, 2, 3, because there's 3 at a time in that permutation. So then 8 times 7 times 6 gives me 336 for my answer. So try this one. Try to find this permutation. All right, so 12 things, 2 at a time. So you start with the biggest number, which is 12. And I only need 2, so then I go down by 1. 1, 2. So that's all I have to do is 12 times 11. Okay, try this one. Okay, so I have 4 things. So I started with a 4, and it has to happen 4 times. 1, 2, 3, 4. Multiply all of that together. 24. Because 4 times 3 is 12, and 12 times 2, 24. 24 times 1 is 24. All right, one more try. Alright, what do we start with? Yep.
10, 9, 8, 7, 6, 5. No. Stop. Oh, 6. Yeah.
I needed 5. 1, 2, 3, 4, 5. Did y'all get 30,240?
Yeah.
Okay, I have one more type to show you. This one ties in the permutation into probability. This word problem's a little bit long, so you might just want to write down the meat of the information you need. Alright, so Ashley's MP3 player has a setting that allows songs to play in a random order. Do any of you have that setting on whatever your device is, where you can just randomly play your list? Okay. Shuffle? Okay. Alright. Alright, so she has a playlist that contains 10 songs. I bet you'll have more than that in your playlist, huh?
I have 300 something.
300?
I have 6,000.
Alright. What is the probability so notice we're using this word probability that the MP3 player will randomly play the first 3 songs in order. Alright, so first we'll find our permutation. We've got 10 songs and we're going to play 3.
So 10, 9, 8.
Good. 10 times 9 times 8. So 720 outcomes there. And because we want the first 3 songs in order, there's only one way to make that happen. So it's a 1 out of 720 chance that that will happen.
7.
One more type of example and we're done. Alright, so we have 2 different letters. Are randomly selected from the letters in the word math. What is the probability that the first letter selected is M. And the second letter is H. All right, so we'll find that permutation to know our total outcomes. So there's 4 letters in the word math, and we're only going to choose from the first and second letters, so 2. So that would just be 4 times 3, 12 total outcomes. And there's only one way to let the first letter be M and the first letter to be A, or second letter to be H, because there are no repeating letters. So the probability is 1 out of 12.